everyone. So let's solve today's POTD, which is largest combination with bitwise and greater than 0. Let's understand the question first. Bitwise AND of an array nums is the bitwise AND of all integers is nums. So if I have to find the bitwise AND in my nums array, which is given to me, this here it is candidates. So it's bitwise AND is the AND of all the integers, right? Like for example, if I have to find the bitwise AND of this, so if I have to find the bitwise AND of this combination, it will be AND of all three numbers, like 1 and 5 and 3, which is 1. So how bitwise AND works? So like if I'm doing bitwise AND of two numbers, it will give me the result which have both the set values, like both the bits as a set value 1. For example, if I have this, if I have these two binary representations, which is 1 1 0 0, and another binary representation as 1 0 0 1. So here, if I do the bitwise AND of these two binary representation, what will be my answer? For first position, we have 1 0 and 1 1, so it will not be set bit. It will not set my bit in the bitwise AND. Both are 0. Uh, 1 is 0, 1 is 1, 1 is 1, 1 is 1. So my bitwise AND of these two numbers will be 1 0 0 0. Did you get it, the idea? If both the bits are set, then only we are going to get the set bit in AND. If any of the bit is not set, I'll get bits as not set. So my answer for these two bitwise, these two binary representation will be this. So that's how the bitwise AND works. So you are given an array of positive integers candidates. Evaluate the bitwise AND of every combination of numbers of candidates. Each number in the candidate may only be used once in each combination. Okay, so we can make any combination. It should not be continuous, like 16, 17, 62, 12, 24. Like it's not important that you make a continuous combination. You can make combination of any digits and take that one time only. So you have to return the largest size of combination of candidates whose bitwise AND is greater than 0. So I have to return a combination from here, like in the example 1. So the combination 16, 17, 62, 24 having a bitwise AND of 16, which is greater than 0, and it is the largest combination which is having this, which is having bitwise and greater than 0. So that's why we are returning its size, which is 4. We have 4 elements, so 4 size. So I'll be returning 4 here. An example 2, as you can see, both, if we take both, then only it is a greatest combination, and it is giving me a bitwise AND of 8 only. So I'll just return this. I'll just return its size, which is 2. So how can we solve this question? Let's understand this. How do we know that which is the biggest combination, like which is the largest combination? So we can simply leverage the idea of bitwise AND only. So how my AND got set? My AND will set if that same bit is set in all other elements, right? So what I can do is we can check for every bit, like for the zeroth position, we can check if it is set in, it is set in how many bits, like this. For zeroth position, we will check in all the numbers in which it is set, and we will have a count for it. For the zeroth position, for the first position, we will check in how many numbers it is set, and we will have a count for it. For the second position, we will check in how many numbers that bit is set, and we will have count for that. In the fourth, for the fourth position, we will check in how many numbers that bit is set, and we will have a count for that. And from all those counts, we will return the maximum count. Did you get this? Like we want to return the maximum combination which has, like the biggest combination which is greater than 0, like whose bitwise AND is greater than 0. So we will simply check whose bits are set so that we can return the maximum count, and that maximum count will give me the maximum length of my combination, uh, by which I can make it the largest combination. Did you get this? So now let's code it and you will understand it more better. Okay, so first, okay, so as I told you that we are finding uh, like position wise bits. Like for the zeroth position I'm checking in everyone. For the first position, so how do we know that how many bits will be there in these numbers? So for that we have to check a constraints. So the constraints given to us is for the candidate I, it can go till 10 raised to the power 7 size. Okay, so for that we have roughly 23 bits. If we start from 0, 23, 24 bits, it is the rough estimation of how many bits we have to take. So we will run a loop for that much bits only, 10 raised to the power 7, it's roughly 23, 24 bits. So we will run our loop till 24. So let's do it. For and I equals 0, I smaller than my, okay, I so this I is for the bit, right? So I will be smaller than 24, I plus plus. Now what we want to do is that we should have a count which is going to count for the number of bits, number of set bits which we are getting. So let's now iterate in the auto number in my candidate. So if my number and one left shift to I, if it is something like, if it is set, then just increase your count and have a max count with you, max count because we have to return that maximum length, right? So let's initialize max count maxi here, which is the max count, which is 0, and just return maxi. Yeah, so it's done. Did you get this? One left shift to I. So what this one left shifts I times, what it is doing is, if I so okay, so let me explain it here. Okay, so for one, what do we write? Okay, we can write 001, like, right? So if we left shift it, what we will get for, if we left shift this one, I'll get 00110. Okay, it will become 2. If I again left shift it will become 0100. If I again left shift it will become 1000. If we again left shift it will become 10000, like this. So if we left shift it again and again, I'll get 1, then 2, then 4, then 8, then 16. So it is like the bit position. So we are basically using it to check the bit position at the first position, then second, then third, then fourth, and like this. So this is basically for one left shift I, it is basically for checking the bit position, different bit positions. Okay, it is just for changing our bit positions. So now let's submit a first run it, and now submit it. So yeah, it's working fine. Now let's understand the space and time complexity. So the space complexity is like constant because we are not using any extra space, just some variables count and maxi. So space complexity will be big of 1, and the time complexity will be, first of all, like we are running our loop. Okay, so the time complexity will be, first we are running our loop till 24. So 24 into auto candidate size is 10 raised to the power 5, so it is like call it n. So it is running till big O, big O of n times. Yeah, so this is the time complexity, and space complexity is constant. Thank you so much for watching.